Welcome back to calculus. So we're on to our second example here. This one is not under a fraction, not in the denominator of a fraction, but trig substitution can be helpful here. But I always want you to be thinking about what can I do to simplify before I get going? What are my options here? And in this one, I contemplated omitting this little step, but it happens. You could factor a 4 out, right? And get there. And then that 4 could come all the way out of the square root of 4 is 2. And it doesn't have an x in it, so it can pass all the way through the integral, and we get to this. Okay, now the problem really begins. So we cannot integrate this because if we had like an x out front, like here, which I had to say to put that there because it's not there, you could integrate it, but we don't. You could do a u substitution, but we don't have an x or a 2x or a 5x or something like that. So this is a case where trig substitution will help. So which of those does it look like? Do you remember which one it looks like? It looks like the one like this. A squared minus u squared, right? And on that one is where your substitution needs to be u equals a sine theta. So in our problem, we're going to say u is, what's our a? Square root of that, so 2 sine theta. Go ahead and do your du. Here I go again using u, but it's not u, it's x. This up here is just kind of a general formula. So x equals 2 sine theta, therefore dx is 2 cosine theta d theta. If you want, you could put the dx below. That's fine also. But now I want to build this right here. And this is my favorite part. So to build it, what do I need? I need to first square the x. So square both sides. Then I don't want just x squared. I want 4 minus x squared. So I'm going to do 4 minus on both. So 4 minus that thing. And then before you square root, you always can factor. So when you factor out, you get 1 minus sine squared theta, and that is always a trig identity. That this whole thing right here guarantees when you do this, you'll have a trig identity that allows you to condense it. And now that it's condensed, now that it's condensed into a single term, a monomial, when you square root both sides, you can just square root it all and get 2 cosine theta. So that will be used, and that will be used. And really nicely, well, it seems nice, we simplify this down to 2 times the integral of 2 cosine theta times 2 cosine theta d theta. The 2's come out to become an 8, and we have cosine squared. Like, oh wow, what a great thing. But cosine squared is not so easy to integrate. We talked about this back in 8.3 with the trig power integrals. We actually have to do an identity at this point. You might look back over there, but I'll just make a little note here in my second aside that cosine squared theta we learned back then is 1 plus cosine 2 theta over 2. So we'll use that identity, and we can't integrate cosine squared theta, but we can integrate cosine 2 theta. First of all, the 2 comes out front, becomes 8 over 2, which is 4. And so really this is our problem to work with. Okay, so we're ready to integrate. Integral of, what is the integral of 1? D theta. It's theta. Okay, we've seen this a few times. It's tricky the first couple times we saw it, but look at your variable of integration. It's theta, so the integral of x is theta. The integral of 1 is theta. Don't put x, because we're going to go back to x later. But we're all going to all in with theta or all in with x. Right now we have theta. So it's theta plus, what's the integral of cosine 2 theta? Well, it's going to have a negative. I'm sorry, it's not going to have a negative, but it's going to be sine of 2 theta, right? Because the derivative, let's just kind of, if you want, you can do use substitution if you like, but we know, just this little side here, the derivative of sine 2 theta would be 2 cosine 2 theta. There'd be this extra 2. So to absorb that, we put a half there. So check it. If I took the derivative of this, I'd get 1/2 times 2 times cosine 2 theta, which would just be cosine 2 theta. Okay, we're getting somewhere. Let's factor this half out of here. So we factor it out. You have a 2 out front, which makes a little bit smaller numbers. And then what's going to happen with the theta? It's going to be 2 theta. Okay, fractions are gone. Feel pretty good about that. Now we want to go back to x's. I did A3. So our fourth aside, again, the third one really wasn't, the second and third one really weren't necessary, but just trying to make things organized, our notes here. So usually what we want to do is we want to look at what's our connection between the theta and the x world, and here it is. In other words, sine theta is x over 2. So I need to find out what theta is for this one, and what sine 2 theta is for this one. That's weird. Well, the theta one is easy. We know that theta is just arc sine, or sine inverse, right, of x over 2. Now, normally we call it arc sine, so we'll stick with that. So this is going to be 2 times 2 arc sine x over 2. Makes it a little easier to see. Now, what's with the sine 2 theta? Can I just double this? Hopefully the answer is a strong no. You cannot double it. That's not how it works. Sine, let's write this common here. Sine 2 theta is not equal to 2 sine theta. No. That 2 is in the action. You can't just pull it out front. So what does sine 2 theta equal? What can I do with it? Well, you know, we have the 11 identities that I think are the key identities of trigonometry. And then we talked about the 12th identity that came along and decided he was worthy to be among the other 11, and now they're the 12. That's sine 2 theta. Remember what it is? Sorry about that. Sine 2 theta is 2 sine theta cosine theta. So let's do that. This is equal to 2 sine theta cosine theta. So a bit unusual here. We have some x's and we have some thetas. We still want to go all in with theta. We know what sine theta is. Now this 2 out front really is kind of annoying. I don't think it's really worth it to factor it out, so I might put it back through in a moment. We know sine theta is x over 2, but we don't know what cosine theta is just yet. So what is cosine theta? Well, finally we do have to draw our triangle. Just put an arrow there. That's theta. Sine of theta is x over 2. That's x. That's 2. So this side would be square root of 4 minus x squared. You can check me on that. This video is getting pretty long already, though. This problem, I guess we're not quite to 10 minutes, but it's going to be a long problem. So check me on that, but that's right with Pythagorean theorem. So therefore, cosine of theta, which is what we're looking for, right? Cosine of theta is adjacent over hypotenuse. And again, notice this 4 minus x squared. Does that look familiar? Square root of 4 minus x squared. Look at that, right up there in the beginning. We saw that. And that's what tends to happen in these problems. You see, it kind of comes full circle back where it started. So here we'll put square root of 4 minus x squared over 2. Hey, what do you know? We're going to need that 2 out front. Let's go ahead and distribute the 2 through. We have 4 arc sine x over 2. That's going to cancel. And then when this 2 is distributed there, it's also going to distribute here. And it's going to cancel with this one. So it's just plus x square root 4 minus x squared plus c. Pretty involved, right? But the idea, and I think we might have done this very problem. Let me look at it again. I'm not sure, but if you took this derivative right here, whoops, if you took the derivative of that, it wouldn't be that hard, really. I mean, you know, that's got a formula. That would need a little bit of, that need product rule, this second half here. But you get back to this square root of 16 minus 4x squared. Good stuff. So it's involved. This is, I think, the most complex thing we do all year in terms of lots of steps, lots of diversity. But once you get the hang of it,